Go ahead.
Yeah, all right. Thank you very much. Okay, and I would say good afternoon, good evening, and good morning, everyone. Thank you very much for joining. I'll just start with my a quick introduction, basically about me. So I think you might have already seen my profile if you have joined this session. So I'll try to cut short. So I've been actually working in the integration domain for the past 12 years. I did work with multiple integration product, and especially my favorite one is web methods and web methods product stack. So I have very good expertise with integrating devices, applications, data, pretty much anything to do with integration. That's what I've been doing. So I also have good expertise with Cumulosity IoT. So I've done good device integrations as well. So, and one of my favorite topics are microservices and DevOps. So I keep blogging about these things in tech community. I love blogging. And pretty much I've spent all my career into engaging with customers and delivering solutions and doing a lot of consulting and so on. So currently in my role, what I've been doing is I've been working as a kind of a integration solution architect, doing lots of cloud transformations, helping customers to transform their on-premise workloads to cloud. So that's what I've been doing. So I will get into the session. So just this kind of the uh, agenda that we posted initially when we started when we basically initially created the event. But I also have a case study, though this is the agenda. So we start with basically quick introduction about cloud computing. Pretty much, I think most of you might be aware of cloud computing, but we'll just do a recap of it. Not too much. We'll just spend 2 to 3 minutes time, and then we'll get into the actual topic where we will discuss about the challenges when we are actually doing a cloud transformation. And I have a special case study drafted for us to kind of discuss about the kind of challenges that you would face during the cloud transformation. And then we'll get into basically what are the options you have available when you're actually doing a cloud transformation, whether you want to go for a IPAAS or you want to go for a kind of cloud native deployment, whether it could be private cloud or as a public cloud. And then what could be a suitable strategy when actually going to cloud? What kind of factors that could help you to do this kind of a transformation? And then one another important aspect is the integration patterns, how they actually evolve. Right. So that's what we would be discussing. So with that, right, let me get into kind of the actual topic. So let's talk about basically the cloud computing. A quick recap. So pretty much, I think everybody might be aware about these days. Cloud is something which you keep hearing each and every place where you go. You keep hearing about cloud. So yeah, public cloud, private cloud. And multi-cloud and hybrid cloud. These are the flavors which I would like to kind of um, uh, present. And then basically, especially right, a public cloud, you choose basically when a customer actually first want to do a cloud adoption. This is the first place where everybody will go. They will try to go to public cloud because it doesn't require any upfront investment from an organization standpoint or a cost standpoint. And then you do kind of a quick validation whether it's suitable from a security standpoint or a cost standpoint and all those things. And another advantage what you get is with public cloud, you will also get kind of a high scalability because public cloud is more elastic compared to basically the rest of the flavors. And whereas private cloud is something where you would stand up where you want to kind of a control what kind of a exposure you want to have to the cloud. Basically, it would be completely managed by you. What kind of resources are exposed, what kind of data is exposed, which gives you more control and better security compared to the public cloud flavors because you have only limited control there. And coming back to multi-cloud, this is the most happening thing nowadays. Everybody is about multi-cloud because usually either of the public cloud or private cloud, they have a vendor lock-in as kind of a impact. You would kind of depend too much on one cloud, and you would end up in a situation where you cannot get out of it. So this is the reason, one reason why people do go for kind of a multi-cloud initiatives. And another reason is because uh, most of the cases, if you choose the cloud providers, not all the services would be suitable for our use cases. Like you have a possibility of pick and choose the right service from a right cloud provider. This is another reason why you go kind of the multi-cloud initiatives. And of course, definitely high availability, because if you have any zone loss from a one cloud provider, you still have another cloud serving the business without having any impact to your business. And as a matter of fact, hybrid cloud is something which has been there for a while. Though I've not actually spoken about it, hybrid cloud is just another flavor of multi-cloud, where you would just not only do the multi-cloud, but also you would integrate your existing traditional on-premise infrastructure. Though everybody wants to go to cloud, it's not just that easy to basically just get rid of the existing infrastructure and completely move to cloud. That is something, though everybody wants to do that, it's not that easy, because you will always have some kind of a legacy applications running in your on-premise and traditional data centers, and which you cannot actually modernize them, but you might want to kind of connect them with the modern deployments, whatever you plan to do. So these are the kind of flavors which we would take in the coming sections as well. Just a quick recap. Then and whenever somebody does this cloud transformation, right? So what they would think is basically what should be the right deployment model. Basically, should I go to public cloud or private cloud? This is easy. Basically, your nature of security and data and control, you can easily choose. But the deployment model is has been always kind of a challenge when you're doing a cloud transformation. And also, so the integration patterns, basically the classic enterprise integration pattern. If you're from an enterprise integration background, pretty much you would know there are four famous patterns people keep talking about: file transfer, shared database, messaging, and APIs. How does these will transform? I'll give you a use case which will talk more about the challenges when you're actually transforming to the cloud. And is it only about actually just the integration? I mean, if you're from an integration background, we do know that what is integration bread and butter. Pretty much, it could be system, it could be syncing the data from one place to another place, and so on. But is that the only challenge that you would face, or else there would be new challenges? Basically, you would have to factor in. So these are the topic actually we will discuss. So. Then this slide actually talks about the same aspects. Basically, let's start with it. First challenge number one, I would say this slide actually represent one of few key challenges, but there would be lot more challenges to kind of factor in. So starting with cloud is decentralized. Basically, you would see most of the cloud providers uh, having the SaaS, PaaS, or else whatever the service offerings, they actually scattered across and deployed across different regions. You might be located in one region, and your service that you're connecting to might be located in different locations. Even just if you take an example of AWS as Azure, they do have a lot of geographical locations in every region. So that is one problem. And that too, if you consider the SaaS endpoints, right, they're pretty much infinite. Actually, they keep coming. You keep seeing every year. You keep seeing a lot of services launched by the cloud providers themselves, and also a lot of SaaS offerings. Because that's a market everybody is trying to grab, and every time you see a launch, you have a new endpoint to integrate. And then uh, especially this is something which you might be interested as from a being from an integration background. So typically whenever there is an endpoint, if you see, right, they usually try to focus on their own line of business. You would see whenever you're integrating with a particular system, you are kind of forced to adopt their integration and interaction styles. Basically, they will have their own technologies. For example, if you take an example of SAP, most of their integrations are based on OData. Even Salesforce, if you take an example, most of their integrations and APIs are OData in nature. And if you take the success factors, they're RESTful and also SOAP in nature. So you have different interaction styles, different technologies, and different data formats. Basically, if there is a piece of information available in one SaaS endpoint and you want to sync up with another SaaS endpoint, both of the data formats would be completely different, and you would end up actually kind of sometimes find them inconsistent. In some place, for example, somebody might say that yes or no, and in another system they might say that true or false. Just an example. Even the data formats might not be uh, consistent as well. So we might have to make kind of a come up with a strategy where we would consistently integrate these inconsistent data formats. So and then hybrid user communities. So I mean, when we are actually doing these cloud transformations, the mindset is slowly changing. There was a time where integration is only done by the expert technical integration developers or designers, but now it's actually changing that everybody wants to kind of quickly build an integration and then integrate in few minutes to hours. Basically, that kind of agility is what people are expecting. So and then integration patterns are also evolving. So we'll talk about this part. So how we'll take a use case and we'll talk about this. What is this distinct integration pattern when we go to especially to cloud? And of course, disconnected networks. What is a disconnected network? Just an example in this picture, you see, right? You have public cloud, private cloud, and you have a traditional infrastructure. Everything is located in a different network. Every network has its own security requirements, starting from IP whitelisting and also from kind of uh, uh, connecting both. If you consider a private cloud and if you want to integrate private cloud and your traditional on-premise, you might want to kind of set up a hybrid link between them. And so same as with public cloud as well. And most important thing is the security. When you have these many systems scattered across different endpoints, each endpoint has their own security requirements. And again, how do you integrate becomes again a challenge, and also how do you protect them becomes also a challenge. So a few key challenges I've highlighted here. So typically, right, this is a classic pattern everybody follows when you're actually doing the cloud transformation. It's easy to say. They will say that, come back and say that, hey, why don't you go for a Gartner 6 hours strategy? You retain, rehost, rebuild, replatform, and re-architect. Let's spend just few minutes on this particular slide. So you can see each strategy with amount of time each strategy would take, and also you would have an opportunity of optimizing and also bringing the business benefits back in whenever you adapt such a pattern. So first one, retain. So retain means basically, let's say you have a system in your traditional on-premise infrastructure and you want to do a cloud transformation, and you've realized that basically you cannot actually just take it to cloud because it has very tight dependencies with your backend system, and it has to retain as is. But especially I actually represented here as encapsulate. So what this means is basically when you're returning, don't just only return as is, but try to encapsulate this in a way it is API-fied, and also kind of if possible, convert that into kind of a cloud native deployment and retain. Just don't retain as is, but you also try to think about how you can actually uh, 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 transform the existing deployment into a cloud native deployment and then keep it as is. We'll talk about also cloud native deployment when we go to the end of the session about the deployments when we talk about it. So that's about basically retain, and you do have basically it's a quick win actually. Whenever somebody, I always recommend my customers whenever they want to say that, hey, I want to basically modernize my platform. If you not only about basically doing a cloud transformation, but also about basically whenever they want to kind of modernize, right? Hey, I would always recommend, why don't you actually convert your existing deployment to cloud native deployment? Cloud native deployment actually refers to more like a containerized deployment. It's a quick win. You don't have to change anything. Everything remains the same thing. It's just that the existing VM-based installations, you're actually slowly converting that into a containerized deployment so that it becomes easy. You can deploy it in on-premise or in future and also to a cloud. So nothing changes, no code changes, nothing required. Only infrastructure-wise, you encapsulate into a bundle, which can be basically deployed anywhere, literally anywhere in on-premise today or in future to a cloud. And also the another advantage you would get if when you containerize, right? You can also scale it dynamically. If you bring it into a platform like a Kubernetes, right? You can scale it very fast when you containerize. But even when I say encapsulate and containerize, it's just not only just containerizing and just leaving it, not immediately deploying it to something like a container orchestration platform like Kubernetes, but just containerize as a first step. Just run it as a plain container, standalone container, which is a quick win, which does not take too much of a time. That's what the first thing step means. Retain your existing logic as is. Don't change anything. Just encapsulate it and think about how you can actually API fight. That means basically identify all your capabilities and see if you can actually expose them as reusable APIs to whoever is actually consuming it, if it is not done already. So that's what the first strategy. Quick win for anybody because you don't have to make too many code changes. Only infrastructure level, very small time and material is need to be invested. And the second part basically is the rehosting part, which basically is also represented as lift and shift basically. So rehost means basically you might be running in a traditional VM. The first one what we have seen is retaining. Retaining means basically you would retain in the same VM. It's just that installation you would containerize and run it in the same VM. Typically, right, in a traditional infrastructure, if you're running any instance, you might also have to talk about basically, hey, how do I need to open the firewalls between this server and that server, whether these are able to ping each other, and all those things will come in the first factor when you retain it in the same infrastructure. When you encapsulate it and run it as a container in the same infrastructure, that pain is taken away. But whereas in when you say rehost, think about rehosting it to a better platform. And probably if you want to go to a cloud, right, you might want to think about basically how do I put it into something like a Kubernetes platform, which is more scalable. And if you're going to cloud, you can utilize Elastic Kubernetes services or Azure Kubernetes services, which is basically they give lot of returns when you actually rehost into those kind of a containerized platforms. So you're just lifting your existing infrastructure and shifting it to cloud. That's what it meant. So it would take slightly more effort, but it has a lot of business benefits because a lot of cases we might see that when everybody runs production in a clustered environment, right? You'll have 2 or 3 nodes running, always serving the load, whether they are actually utilized or not. But when you go to something like a container orchestration platform like Kubernetes, what you can actually see is you can dynamically scale down or scale up. Whenever there is a business need, you can actually scale up. Whenever there is no need, you can scale down automatically by defining the resource usage and the scaling guidelines. So it actually gives a lot of optimization and also business benefits. Since you have already encapsulated, right? This should be the first step if you really want to go to kind of a cloud. And there could be cases where you might actually want to rebuild and replace the existing things. We will talk about this factor actually when do you want to kind of rebuild and replace part slightly later. We will talk with the use case that will give you more advantage. Basically, this is self-explained. Basically, you would kind of completely get rid of your existing and retire completely, and then replace with some a better approach, maybe something like an IPAAS. You go to cloud and you don't want to maintain an infrastructure. So we'll talk about with an example. And then there is another, again, it has its own cost. You can see the cost has increased. And of course, when you're actually transforming to cloud, it will have its own benefits as well. And another part is replatform, which is actually represented as lift, think, and shift. So uh, when you're actually thinking about replatforming it, you're not just only taking the existing logic as is and shifting it to cloud. And this is where the patterns will come in. So when you're actually transforming to cloud, our integration platforms no longer will become as is. I think there might be a scope of improvement. So what is that improvement is what we will basically pretty much see. And of course, refactor and re-architect. You would also basically not only just change the patterns, change the way basically the systems are talking to each other, but also you would change the architecture itself. Basically, more think more like a going towards a microservice architecture, or else going towards basically combination of microservices and the IPAAS based architecture. I mean, these are the kind of strategies everybody usually refer. It's a kind of a book that is actually given. Anybody who would want to go for a cloud, they would actually refer to this. But pretty much, right, whatever it's very easy to say that, hey, this is what you need to go do, but it's that not that easy basically. So uh, what eventually, whatever the strategy you would choose out of those the 6 Rs, right? Pretty much what you would do is first you do a consolidation, basically assess and assess the needs of the integration and deployments. Basically, do I really have to go to IPaaS, or do I really have to go to public cloud or a private cloud or as a multi-cloud? Do I need to containerize it? Do I need to basically deploy it to a Kubernetes platform? So what kind of time it takes, what kind of a cost actually requires, what kind of benefits you would get based on all these factors, you would consolidate that. Hey, I might not actually take all these things. I don't. Maybe some of them I might retain. Some of them I would actually lift and shift because these will address a different set of needs. Some of them might need to be rebuilt completely on cloud. Some of them can be kind of a replatformed, and then pattern can be changed. So uh, and then completely reshaping the architecture into microservices. Again, these kind of a things is what we will do typically, and we will see that with an example. Let's see a case study. Actually, this case study, whatever I'm talking about, is something which I have personally worked, and I've seen a lot of challenges with this customer. Uh, so there is one customer actually who approached when I was actually working for services with this customer. So what their challenge is, basically they have been actually using web methods from like a 6.x version, and they've been actually they have lots of file based integrations, and they have a lot of database systems, and a lot of systems are communicating to each other using schedulers. They're exchanging information. A lot of systems are communicating to each other using messaging. They were using broker, and they migrate to universal messaging, and then they're still using both native publish and also basically kind of a JMS send and receive patterns, and they do have SOAP APIs and REST APIs. This is pretty much what you can expect from any web methods customer, because web methods has been there in the market for a while, and a lot of customers who use web methods are very happy because it's a very stable platform. Whoever basically uses this, you would pretty much see the same thing, not more than this. Of course, this talks mainly about pure system or API integration, not partner integration. If you consider partners, you would see pretty much a lot of B2B transactions flowing in. I've not factored that in because it's a real use case. So this is the basically current state when they actually approached. So how do we solve it basically? So what they thought is basically without even basically thinking or assessing what their existing architecture. So they have their own cloud architects. They came up with kind of a theory saying that, hey, I would just basically completely take out my existing on-premise infrastructure. And one of the challenges, they have a big initiative going on, and they don't want to have anything running on their on-premise. But unfortunately, some things they cannot get rid of it. That we keep talking about this, right? Some, though everybody wants to go to cloud, few things they could not get rid. So what they had is basically they had still a lot of files generated in on their on-premise infrastructure, because that's where they have the source. Basically, their source is still on on-premise. They cannot get rid of it. They will have a lot of files still generated on on-premise. What they were hoping is they would completely remove their on-premise infrastructure and they want to go to IPAAS completely. They want to go to cloud, and they were hoping actually they would just simply lift and shift to cloud. And another big challenge I wanted to actually explain here is when you talk about IPAAS, it's usually typically on public cloud. You would see the deployment on public cloud, and public cloud deployments usually will not have the connectivity to traditional on-premise infrastructure. If you need to have a connectivity, you need to have a hybrid integration. Hybrid integration just for information, hybrid integration means the you need to have an agent running on-premise, an integration agent running an on-premise. Integration agent is nothing but integration server running in on-premise, connecting to IPAAS means web methods IO, connecting to web methods IO, taking these files and shipping. And they don't want to have it actually as well. Literally, they don't want to have any infrastructure on their on-premise, and they cannot have direct connectivity to their on-premise infrastructure. And there comes in another complexity basically. So the complexity is basically they have a public cloud. You can see that represented as public cloud here, and all their databases, whatever they have in the past on their traditional infrastructure, they want to kind of migrate, because a lot of public cloud services, they do offer database migration services. They want to utilize those database migration services and then just shift entire data there and schemas there. And they wanted basically the public cloud to connect with IPAAS, which is hosted on software managed public cloud, and with the public cloud with the VPCs managed by uh, themselves, where they have database services basically provisioned, which are not exposed to internet. And that public cloud is connected to on-premise via hybrid link, maybe something like a direct connect or Azure Express route. Just an example I'm giving, right? So is this actually possible? This is how they came up. They landed with us with a problem saying that. And if you see the problem challenges here, right? So existing files resides as is, and no presence of runtime, integration runtime in on-premise. Problem number one. And problem number two is basically they want to lift and shift their entire workload with very minimal changes. Basically, they want to go at one shot, lift and re-architect and reshape, whatever you want to call it, directly to IPAAS, because they don't want to manage any infrastructure, because they had a big cloud transformation program going in and a lot of applications are going to cloud. They thought they will go simply like that. Just an example, in particular, if I have to give an example, right? When they came with this problem, they are using my web in the server, and they had a lot of user interfaces and tasks implemented on my web server. They were even hoping that their user interface and tasks are migrated to IPAAS. I mean, they are that naive in when they came with this problem. Is that possible? Actually, literally, it is not at all possible, because usually when you are actually doing a cloud transformation, you have to kind of uh, just you cannot simply lift and shift. You will have to lift, think, and shift. So it's not possible, which this is an indicator of basically they have not done a proper assessment what they have on their current integration landscape, and what is the roadmap towards basically when the roadmap towards the cloud when they go to cloud. Problem statement still basically no solution for it, still a problem statement. So then let's look at basically how do we solve it. This is a problem statement. We don't have a solution. We need to solve this. So uh, just like this picture represents, they're under confusion. Basically, how do they solve this problem? So their primary choice is basically, let's start. Okay, they thought let's go to Webmas IPAAS. Yes, it's a great platform. But is it a like-to-like replacement is something which they don't have an understanding. So they started with this basically. But if you see, right, anybody whoever wants to go to a cloud transformation, one of the options what they will have is the one which I'm showing. Basically, if you want to go with WebMethods IO, so if you can pretty much see WebMethods IO as a center of the connectivity. So you have the left-hand side public cloud, whatever the SaaS service you have, and private cloud, whatever the private services or private APIs, private implementations that customer would have. And if you have an on-premise workload, you would have an on-premise integration agent. Um, And if you want to kind of expose that as an API, you can have a web methods API gateway, which is represented as Edge API gateway here. And again, on the left hand side, micro gateway. I mean, this is a huge, large scale. Every web methods developers would like to see this kind of a deployment, like because you would have pretty much everything here. You have web methods IO, methods B2B, API. Connecting to all the cloud offerings, and also you have on-premise connecting to all the legacy systems with all the adapters and everything. One of the advantage with this model is you don't have to worry about connecting to cloud hosted SaaS or PaaS or IPAAS or whatever it might be. You don't have to worry about getting connected to different SaaS endpoints, because you are having the out of the box shipped um, connectors. Web's IO integration platform would take care of it. So you can easily connect within few minutes. You just configure the endpoint credentials and then get the required tokens, and then boom, you're ready to go. Using workflows or integration, you can easily integrate. But traditionally, if you have any traditional application, you can still connect them using basically on-premise hosted WebS integration server. So this is one option everybody would have. We don't know whether this is the right solution for this one. And another option what you would have is basically a lot of customer does this actually these days. Actually, there was a time where initially everybody wants to go to IPAAS offerings, but there are some customers who realized actually that they have, and especially if there is a new customer, brand new customer who is actually coming and implementing any new integrations, I think this IPAAS hybrid multi-cloud integration architecture actually is well suited. I do have worked with, I did work with customers who did this actually. They started from scratch. They started building the integrations on cloud from scratch. If it is greenfield implementation, it would be very easy, the solution. But if there is an existing customer, and if they have tons of integrations running already in their on-premise, and they don't want to actually kind of reinvest building all those integrations, this is something which would help easily to kind of lift and shift their integration logic, because pretty much the runtime wouldn't change, and also the deployment also would be into their control, full control. What you see there on the top, still connecting the left hand side public cloud and private cloud, uh, is basically something exactly similar to what you have seen in the IPAAS, something similar to WebMS IO integration. But you would, instead of WebMS IO integration, you would have your own infrastructure, maybe containerized, running in a Kubernetes platform, or else it could be even VM based. There are customers who are actually still deploying the runtimes, integration runtimes on VMs, on cloud, on public cloud or private cloud. There are still customers because they're not yet enabled in terms of the skill set. They're not yet enabled with, but I mean, I would say pretty much if somebody is actually going to cloud, I would highly recommend to actually see uh, if they can actually contain and deploy, because it actually gives huge benefits instead of deploying it to VMs. So this is another model, pretty much exactly same, but only difference is being basically here you can actually control, and you can actually, you might be having already existing API-led connectivity or API-led integration architecture available. You just have to kind of lift and shift with very minimal changes to basically your logic. Of course, lift always the, I call it as a lift, think, and shift. Basically, you just don't lift and shift. You can actually optimize few things here and there, and we will talk about those cases in the coming sections. So where you have a system APIs, process API, and experience APIs, this is basically pretty much what we've been doing. This is nothing but overdone. Right. This is another option that anybody would have available. But are these the straightforward solutions for the problem case study that we have seen? Not actually true. So, I mean, a few factors actually that can actually help to choose if there is a customer, right? I would always say that based on the user community, we discussed about user community. If you have kind of a integration specialist, a mix and match of basically integration developers, like ad hoc integrations or integrators and citizen integrators, and also digital integrators who want to actually build integrations on their own, self-managed, and quickly want to basically build integrations, right? I mean, then IPAAS is a very good option. And also, if it is a greenfield implementation, it is always and pretty much I think I would say that go for IPAAS, because if anyway you're going to cloud, you are going to need the cloud hosted the IPAAS full power. And when somebody doesn't want to have any operational overhead, that's also a factor where you can actually go for an IPAAS. But I mean, me being a web-based developer, I would always enjoy the full beauty of web methods. If you see, right, if you have an integration server, you can pretty much control and build what you want to do. Because IPAAS, though it is actually having a lot of beauty and agility for building integration, it also has kind of a some kind of a guidelines in terms of how you can actually implement the patterns. We will talk about those patterns. Just an example I'll give you. So if it is self-managed platform, you can actually pretty much scale up and down based on your load. Whereas with IPAS, the scalability is there, but it actually comes with basically a cost. When you're actually using a public cloud, it's a shared platform. You would have to use and build your integration patterns in a way you don't actually basically entirely consume the power of the platform. Basically, for example, I'll take a not only Webness IO IPOS, but also every cloud vendor always put a limit. So you always implement your integrations or your what are the APIs you're implementing, what are the integration you're doing. It also you need to put a guideline saying that, hey, I can process maximum of these many records at one shot. Or else I can return you for this API, I can return you maximum of basically 200 record, and then you would have to paginate. Those kind of limitations you would have to keep in IPOS, because it's a public and shared platform. So whereas when it comes to basically the self-managed one, right, it's no longer shared. You can focus on what your organization basically wants, and you can scale up and down whatever the way you need to, because whereas you don't get that kind of a comfort what you've been doing. So me being a web methods background, and I've seen the beauty of on-premise deployment, I always enjoyed the self-managed hosting. So when you go to cloud, so and especially when you have tons and tons of integrations, right, and when you want to have a full capability of webMS integration server, that's where you go for a web methods managed one. And then when you want to kind of fully control which version you want to run, basically, and what kind of a license you want to use, it also comes with a cost whenever you're actually scaling, right? So and also when your integration pattern and workload has a very strong influence, just like the examples I've given, right? That's where you go for kind of a self-managed hosting. So uh, now let's see the integration patterns, right? These are the basically we being kind of a classic integration developers, pretty much this is what we see like a very famous known one. There are a lot of sub variations basically for each of them, but main things, if you go to enterprise integration patterns, cookbook, even this is what you see: file transfer, shared database, messaging, and API pattern. And irrespective whether you go to self-managed or IO-based deployment, right? How does these actually gets transformed? Let's see that. So these are self-explanatory. You don't have to actually explain them. So let's start with file transfer pattern. And I want to actually give an example. I had an experience very recently with this one. So whenever you're actually doing a cloud transformation, and especially when you're actually doing file transfers between multiple systems, right? So classic way is basically you might actually use file pooling, or else you might use an SFTP or FTP. There are cases where people actually does still send files using emails. There is an email port listening to and then basically starts pulling out all the attachments or email content that is received, or else you can even do it with the local files. Traditionally this is what we've been doing. But when you go to cloud, you need to actually be very careful. Not only go to cloud, but also when you are actually containerizing itself, you need to think about basically what would be an impact of a storage. Because storage works completely different than a regular VM based deployments. And also when you go to cloud, if you go to IPAAS, storage is completely ruled out. That's what I mentioned, that it comes with kind of some guidelines. How do you need to practice a file pattern? Let's say in a web methods IO you want to transfer files. How do you do it? You can't actually definitely do it using file polling, SFTP. Yes, you can do, but email ports and local files concept and all these things basically need to be refactored completely. You need to think and then reshape basically the way you transfer the files. Just an example, right? Whenever you go to cloud, of course, you would have to use a cloud storage that's given, something like a AWS S3 or Azure Blob Storage. And if you're going to private cloud, you might want to use MinIO. These are all the kind of options that you have available. And of course, you can use SFTP as well, but that is less often seen. Usually, the storage providers are kind of a very much famous in cloud. So just an example, if you see, right, I'm not sure whether you guys know or not, there is a beautiful feature recently launched, Apache Packet with web methods. You can pretty much see this. I'm just showing it in here. So Apache Packet is pretty much the very famous format where everybody uses it with big data. Whenever you're integrating with big data systems like Hadoop or anything, you would see that if you go for the formats like Apache Packet, right, you can see the comparison. If you use if you store a file as a CSV in S3, it actually takes basically. I just copied these from Apache Packet website, these stats. But if you see it, it actually takes 1 TB if it is a CSV file. Same thing if you store it basically in Apache Packet format, it actually takes basically very little compared to 1 TB, 130 GB is very less. You would have basically 87% of savings basically. And even when you're actually querying or doing a lookup, they're compared to the lookup with CSVs is much faster, and then the cost as well. So I don't, this is self-explanatory itself. So because when you're actually doing a cloud transformation, cloud comes with a cost. Just because we are going to cloud, it doesn't actually reduce the cost. Everything comes with a cost because we are just using all the cloud resources. We have to use them very intelligently. So you would have to cut down the cost. You would have to optimize your implementation so that you're doing the transformation in a right way. So cost is also a factor for is a big factor for cloud transformation. This is one example. How do you, when you need to think about basically how do I need to basically reduce the cost and how do I optimize my file transfers? And when you're actually going to cloud, you need to think about basically public storage providers, and pretty much it's the same applicable. If you're on webmethods IO, you use pretty much any connector available. If you're using self-managed hosting, you would use cloud streams, and you do have the connectors available. And of course, you can pretty much see the connectors page. There are a lot of connectors available with the storage providers. You would use pretty much either of them. Just an example, how the file transfer pattern transform. And how does the database pattern transform? Though, I mean, I have not seen anybody actually exposing database directly over the internet. Pretty much, if you're coming from an enterprise, uh, you would be really challenged by security team if you're exposing your database over the internet. Pretty much, I would say think about how do you need to protect your database with an API, because APIs gives you complete control over about how do you need to protect, what kind of authentication authorization you need to bring in, um, and at the same time, basically, and when you're actually exposing to cloud, you also need to put boundaries. Basically, always design for the failures. Basically, you need to put the boundaries. How do you put basically throttling? Because the data source itself is exposed to internet, right? So if you really have to expose the database, I mean, this is very less often seen. Even if it is exposed, pretty much people will not expose to public cloud, but they will have a private cloud hosting, and they would only expose to trusted endpoints. Even though IP wet listing is there, I would say that this is something which I always discourage. Think about how do you need to expose. That's why most of the cases what you see is cloud providers, when they actually offer database as a service, they always actually expose the APIs. They don't actually expose direct connectivity. Of course, you do can expose. There is a possibility, but they always protect it typically because it's a system of record, right? You don't expose it. So your shared database pattern is, I would say that this is something which you might want to APIfy it. You might want to kind of put an API in front of it, or put an integration runtime in front of it, and then expose it. Or else, if the cloud provider is already giving an API, use those APIs to integrate it, which becomes much easier when you're going to cloud. So uh, then when you have a messaging pattern, right? I think when you go to cloud, we might be thinking like classic messaging, publish and subscribe, JMS send and receive very well when you are exposing your endpoints to a limited and protected set of consumers and trusted consumers. When you go to cloud, right, you have infinite endpoints. And usually, right, when you go to cloud, most of the cases you would see API is being kind of a mode of exchanging pattern. So that's where the webhooks comes in. Basically, if you're traditionally using the messaging, traditionally you might be using broker or a universal messaging. When you go to cloud, uh, uh, don't think about basically how you can actually change them or migrate them to more like a cloud service offerings, more like a SQS, PubNub, Service Bus, because they're actually made for cloud usage and they're protected on those lines. Public endpoint, never expose your uh, messaging endpoints. That's a ground principle you might not want to actually look at. And if possible, see if you can actually integrate using basically webhooks or callbacks. These are also equally very much equal to basically what we have been doing, more like a kind of a webhooks also provides a mechanism. If you are just an example, if you have ever done an integration with um, GitHub or else Jenkins or else even Facebook, what they would do is basically they will say that, hey, come and register for a webhook. We can go and host our endpoint. Whenever there is an event, they will only call our API instead of just basically sending and receiving. That's a more matured way of kind of integrating when you go to cloud. This is how basically event-based integration transforms because of the nature of the consumers are changing. So you might want to go for more like a cloud hosted messaging services or else more go towards basically callbacks and webhooks. That's how the messaging pattern would transform. And what resides as is if you have already been using the API-led API-led architecture, and if you're using API-led integrations, you don't have to change anything. Pretty much, I would say that it would reside as is, which not much changes required. So because you can pretty much reuse the existing APIs without any changes. So and but if you have to connect to external systems, right, you might want to actually rely on cloud connectors again. Go for cloud streams, just like we have seen earlier. That's something which will really help you to kind of a transform. Just few examples. So now I think we're almost closing the time. So let's come back to the case study, whatever we have seen, right? So how it actually uh, transforms when you had the same problem statement where you have files, data sources, events, and APIs, right? So what could be the solution for them if the customer, one of the problem statement customer actually told us is they don't want to have any presence and to on-premise. So one basically solution could be basically you can have, they already have their own basically private public cloud deployment, so they could actually have an integration server running with minimal changes because they have the hybrid link available. And whatever the files they were generating, if you see the whatever the files they were generating in on-premise, they could actually continue to generate them on on-premise. But a lot of cloud providers, they do actually provide file sync services. Basically, they can just simply install a file sync service which will ship the on-premise generated files simply to the cloud storage. You can take an example of AWS S3. And as a matter of fact, if you have ever explored Minio, even Minio, MinIO actually provides kind of these kind of a capability where you can actually sync these files. Um, to your public or private cloud deployments. That's a very one good option. Nothing changes. Your on-premise systems continue to generate files on on-premise. But there is a file sync service which actually basically ships the files, and from there onwards, without changing much, maybe how the files are actually connected to integration server, only minor changes required. This is basically lift, think, and shape. You basically make minor changes the way files are basically read. If you're if earlier one is having file polling, you might actually want to change it as a scheduler, which will pull the data from basically what are the storage. It could be files, it could be basically S3 buckets, and then since anyway they wanted to actually go to do the database migration to cloud, you can directly connect. It is in the same VPC or else in a different VPC. They can have a private link to connect. It would be easy, and they can also have their own, basically if they have a and all those things without major changes, they can actually have the same kind of a event integration and API integration done, which could be an easier solution just to the problem statement. If I would say that the scale is very less, and if the problem statement is only to migrate to cloud, this is one option. And the second option could be basically go much better, basically lift and think and reshape basically to the private cloud, and then basically keep it on a kind of a container orchestration platform, something like a Kubernetes platform, leave the existing things running, and slowly start migrating to IPAAS if they don't want to kind of have any presence, and if they don't want to have any operational overhead. This is one option. Basically, this is the first step they should do, and they should slowly start migrating, because IPAAS can connect to basically the storage providers. Basically, for example, if the storage is a problem, IPAAS has connectors to connect to S3 buckets, and it can easily connect uh, to the buckets, or else even the files, and then uh, do whatever it need to be done. And you can also schedule them and slowly do the migration. Then with this, the cost would be less, and you will have a quick win, and then also transformation will become much easier. Again, I have taken a very particular case study where the problem statement is very definite. I do know the problem statement, I do know the solution, so it's easy to actually explain. But when you see the real-time challenges, it's not that easy, basically. So in summary, basically, I would say I'm almost pretty much end of the session. Basically, if you're already having an existing implementation, the first step would be basically cloud native hosting as a first step, because that would actually you could do this in the same on-premise infrastructure without causing more delays. Okay. And you might also basically think about how do you decouple your existing tightly coupled integrations. More like if you have, like just an example we spoke about, basically file polling and all those things, which are very well which are mainly focused towards basically solving the traditional integrations, basically traditional problems. But the new set of problems actually need to be solved using the updated governance. A few examples I have given. uh, in any way, basically, if you want to go to multi-cloud, and multi-cloud is not about basically deploying, having only one type of offering. Cloud native hosting is a winner, definitely winner, because you containerize and you deploy it pretty much anywhere. You encapsulate it. That's what we discussed about it, right? This is what pretty much will is a winner. I've seen success every time customer goes for this kind of a containerized deployment. It helps them to easily transform either to on-premise, either to private cloud or public cloud, or else even to IPAAS. They can easily connect using the integration agents. And this is what I would like to actually talk about. Basically, again, a use case which we have recently done, the cloud native transformations and the challenges that we faced when we're doing the cloud transformation, and we're trying to ship the my integration workloads to AKS. This is what we are planning next month. Just a use case, and I promise it would not be theoretical like what I shown just now. This is just a first session in the series about how you can actually do the cloud transformation. I promise that next session will show you kind of a more hands-on, where you can actually see the uh, live demo. So with this, I would like to actually conclude. Bharat, I would hand over this back to you. Thank you very
Yeah,
much.
thank you, Srikanth, and thank you so much for the informative session. Guys, can you start? I mean, please start posting your questions. I see a couple of questions already, so which I'll be redirecting to Srikanth. So, are there any customers currently deploying web methods in Kubernetes?
Yes, yes.
What's in?
Yeah,
Yeah, it's not over
yeah,
question. So, what
yeah.
scenarios this helps and benefits we get comparing the legacy clustered integration server architecture?
Yeah, first thing I think I might have missed to talk about it. Yes, we do have customers containerizing on-premise as well. In 20, I think there is a use case you might want to actually look at. So uh, there is a use case we'll share basically. This was is so you can actually you can pretty much see this. This is not an actually you can pretty much see, right? Um,
Yeah.
this is not even on SoftwareG's website. So this is one case where you might want to see. This is something which the, this particular customer have containerized on-premise on their private cloud using OpenShift. It's a flavor of basically Kubernetes, and it actually so they were when they started as a small bank, and they have launched a new line of business, and they want to compete with their and Bank BTBN is a very small customer in Indonesia, and after they launched it, they were able to compete with big players. They were the first ones who actually launched the mobile-based banking in that region. So it actually helped them to achieve that agility. That is not something possible uh, on a regular VM-based deployment. One thing to highlight, maybe next session I would cover this, is whenever you're actually going to cloud native deployments, don't go stateful, go stateless. I'll talk about it in the next session. So they did a stateless Kubernetes deployment in 2017, and there are a lot of customers who are doing, I do know, because this is a public reference. I quoted the name, but there are few references which I cannot quote. There are customers. Right now, we are working on a big program where we are doing the same exact thing.
Okay. There's one more question from Nagendra. While migrating to the cloud, how do you avoid the complexity that creeps in due to the addition of seemingly useful but non-essential components?
Maybe I didn't understood the question.
Yeah.
Maybe it's a generalized question Nagendra was trying to ask. Uh, I hope I answered it using the patterns I have explained. I think that's the answer. Basically, you need to take care of basically to reduce the complexity. You need to handle the transformation of the patterns, integration patterns. I hope I answered it. If not, maybe he can ask a follow up question.
Yeah, Nagendra, I'll speak to you offline if you're not satisfied. So there's one more question. I think this is exactly which I have in my mind also. Like, do you have any use case integrated between private and public cloud?
Yes, I mean, pretty much every customer who goes to cloud, they would integrate with both public and private cloud. I can't quote the names, but this architecture, reference architecture, whatever I'm presenting, that was an example of how we integrated. And it was actually, as a matter of fact, it's not multi-cloud, it's a hybrid cloud basically. They do have, I think. You also know this, Bharat. I think you also worked
Yeah.
on this customer. So that's a reference architecture. Basically, we do have a use case. Unfortunately, we can't
Yep.
refer the customer name. Yes.
Right. So I don't see any. Oh, there's one more. If the customer is planning to migrate to IPAAS from on-premise, the biggest challenge is moving the whole mapping transformation logic.
That's correct.
I
That's
don't
correct.
know whether is there any
Yeah,
utility. Yeah, is there any utility this will help?
I would say no, no. This is very valid question because if you're a existing customer, it's a very valid question. So I would say I'm not sure whether you are aware of cloud container offering from SoftwareG in IPAAS. It's a complementary offering in the IPAAS flavors. I will just maybe go back to the slides quickly. Cloud container, you don't have to rebuild the transformation logic. You can use them as is. You can pretty much see in this picture. You see the one which I'm highlighting, cloud container. Maybe let me pointer use. At the laser pointer cloud container is offering. That's your friend. You can just pretty much develop your integration on premise, right click and deploy to cloud. Pretty much very easy. If I have the designer, I do have the designer running. You right click and say deploy to cloud. That's it, done, boom. You have it ready, readily available. So this is, you don't have to rebuild them. You can actually deploy them, which can become basically the connectors. Basically, in Webmathers IO have connectors to cloud container. You can actually call them and reuse them in existing implementation. The cloud container is your platform and utility.
Yeah, thanks, Srikanth. Do you have any cloud service that provides the same capability of Terracotta?
Yeah, caching. I think this is a tough one, but I will try to answer this in a better way. So, caching is a very different topic, because web methods customers, they might be using big data for a while, right? So not equivalent offerings, I would say. If you are doing a cloud transformation, not equivalent offerings available you have, but there are basically cloud hosted basically offerings available services available, which you can actually think about a replacement, because Terracotta is something which you don't have it available on cloud. And there are reasons also why it was not actually brought as a cloud, brought out to cloud as well, because R&D team would be able to much answer this much in a much better way. But you might want to think about basically Redis offering, just an example. If you want to kind of a replacement, that's a kind of one replacement for you. This is one use case about basically replace pattern we were talking about, basically rebuild and replace. Redis is one thing, and there are few more things. I mean, Redis is something which I can immediately answer, but it's a tough one, I would say, to be honest, tough question, because there is no like to like offering available.
I agree. So I don't see any further questions, and currently we are on time, Srikant. Once again, thank you so much for your session, and we'll be waiting for your next session. So, guys, I mean, there'll be a session planned continuous to this one, which we'll be hosting next month. So, which will be continuation to this session, and I just want to close this by saying thank you everyone. Thank you everyone for participating, and I see a very huge
Maybe
number of
uh,
participants.
maybe one, I think, a question, if you don't mind, one question I will answer
Sure.
quickly. The use case I presented is belongs to basically government. Actually, it is from the
Okay.
government. Basically, and that's a solution. Actually, I gave a solution as well. I think there was a question from Kiran Mudula. So this use case indeed is a government use case. I cannot again refer the customer.
Okay.
Sorry, Bharat.
Or this, yeah. So we would like to encourage all of you to share your best practices or use cases like what Srikant did today. So it's not only me talking or Srikant talking. So we'll encourage everyone to share your use case or best practices or anything like the integration patterns or any technologies you want to share. So this platform is open. So you could you could easily come here and you can become a group leader like what Srikant did, and you can start bringing your topics so that you can get the events done. So I mean that's what I want you as an attendees. So you want to be presenters soon. I want to see the more and more presenters from this group, and I like to see this group evolving. So thank you so much. And with that, so sorry we are 2 minutes delayed, but yeah, next time we'll try to close it before that. So yeah, thank you everyone. Thanks for your time. Enjoy your rest of the day.
Thank you.